Hi guys, I'm Hussain, my partner Abby, and we've been solving three quadratic problems and discussing how you solve them. So the first problem is Kaylee wants to build a parabolic bridge over a stream in her backyard, as shown at the left. The bridge must span a width of 200 centimeters, must be at least 51 centimeters from where it is 30 centimeters from the bank on each side. How high will her bridge be? So first of all, we're going to talk about the given. We are given the x-intercepts, which is 0 and 200. We are also given the point on a parabola, which is 30 and 51. Since 30 centimeters from across, it is 51 centimeters high. What we are required in this problem is to find the vertex, which also has a maximum height. Alright, to start off, we will use the equation y equals x plus r x plus s. And since we know the x-intercepts, you can substitute them into the equation, which will equal ax minus x plus 0 and x minus 200. Then we also know a coordinate on the vertex, on the parabola, which is 30, 51. So to find a value, find the a value in this equation, we will substitute these values into y equals ax plus 0 and x plus 100, and then solve for a. So now that we know the a value in this equation, this is minus 0.01. Now we have to find the axis of symmetry, also known as the x-coordinate of the vertex. This can be done through the formula axis of symmetry equals x1 plus x2 divided by 2. So sub them into the formula. So axis of symmetry equals 100. Alright, then we can just sub the 100 into the formula, which and find y. So again, because we know the axis coordinate of the vertex, we sub that into the formula and solve for y. So now we know that the y is 100, and therefore the answer to this problem is the height is 100 centimeters from the center. So on the second question, we see that Leela is creating dog runs for her dog kennel. She can afford 30 meters of chain link fence to surround 4 dog runs. The runs will be attached to a wall as shown in the diagram. To achieve the maximum area, what dimensions will Leela use for each run and for the combined enclosure? So we see that the run is made of 5 W's and 1 L. So we are given the diagram as well as the required fences, which is 30. And we are also required to find the length and width of each run and a combined enclosure, and also get the maximum area. To solve this question, we'll first let L represent length and W represent width. We know that perimeter is 30, and as shown in the diagram, we get it through adding 5W and L. Therefore, the equation is 30 equals 5W plus L. To solve for L, we can isolate it and end up with L equals 30 minus 5W. Now we know that to find the area, you multiply the length and width. The length, which is 30 minus 5w, will be multiplied by width. Which will equal 30w minus 5w squared. Now our equation for the area is, when you factor it, minus 5 bracket w squared plus 6w. To solve it, we will first have to complete the square. So as shown. As you can see, from completing the squares, our equation is area equals minus 5 bracket w minus 3 squared plus 45. From this we can tell the vertex, and we also tell from the equation that we can see that 3 should be the value for the width, so that we could receive the maximum area. We also see that from the vertex, 45 is the maximum area that you can achieve. Now to find the length, simply put the w value, which is 3, into the equation. L equals 30 minus 5w. This gives us the answer of 15. So now from this we know the dimensions of the complete enclosure are 15 and 3. To find for each enclosure, we simply divide the length by 4 to find the length of each of the runs. So 15 divided by 4 is 3.75, meaning the length of for each individual run should be 3.75. Therefore, for the combined enclosure, the dimensions should be 15 and 3, while for each run it should be 3.75 and 3. And know that all measurements are in meters. Alright guys, for the last question, Mark is designing a pentagonal shaped play area for a daycare facility. He has 30 meters of nylon mesh to enclose the play area. The triangle in the diagram is equilateral. Calculate the dimensions of the rectangle and the triangle to the nearest tenth of a meter and maximize the area he can enclose for the play area. So in this question, we are given that the perimeter of the play area is 30 meters. We also know that the triangle is equilateral, thus it has the same side length on each side. We are required to find the dimensions of the rectangle and triangle that will maximize the area of the playground. To solve this problem, we will let x represent the side lengths of the triangle and the length of the rectangle, and let y represent the width of the rectangle. Since we know that perimeter has to be 30, and that there are 3 separate lengths and 2 that equal to x and 2 that equal to y, our equation will be 3x plus 2y equals 30. Now, we simply have to isolate y in order to solve this equation. As you can see, after isolating y, our new equation for y is y equals 15 minus 1.5x. Now we can plug in this value for y to the equation for the area of this rectangle. This usually area equals x times y, and now it's going to be x times 15 minus 1.5x. So sub that into the equation. For the total maximum area of the playground, we have to add the area of the rectangle with the area of the triangle. There is a simple equation in finding the area of a triangle for only the side lengths, which is the square root of 3 divided by 4 and multiplied by the side length squared. Now we simply add the equations and of the rectangle and the triangle. As you can see, the equation to represent the combined area of the rectangle and the triangle can be written as negative 1.0669 x squared plus 15x. To find the maximum area, however, we need to find the x coordinate of the vertex, since it will give us the highest point in the parabola. We can do this by using the formula axial symmetry equals minus b divided by 2a. In this context, it will be axial symmetry equals minus 15 divided by minus 2.1338. As you can see, we received the value of 7 for x, which means that the side length of the triangle and the length of the rectangle equals 7 meters. Now, to find the y value, we plug the 7 into the equation 2y equals 30 minus 3x. After doing so, we find that the value of y is 4.5. From what we know this far, we know that the length of the rectangle is 7 meters, while the width is 4.5 meters. We also know that the base of the triangle is 7 meters. However, we don't know the height of the triangle yet. To find the height, we will be using the Pythagorean theorem, since we know the value of the hypotenuse and the value of a, which can be attained by dividing the base by 2. Now we simply plug these numbers in and solve for b, which will give us the height. And there we have it. The height of the triangle will be 6.6 meters. To sum up, to get the maximum area of the playhouse with a 30-meter perimeter, the length of the rectangle will be 7 and the width will be 4.5 meters, whereas the triangle will have a base of 7 meters and the height of 6.6. The end.